Okay, so basically we're looking at the firstly is the find the payment. Okay, so basically for different loan you have a different monthly payment that you're calculating. So last time we were talking about this. Basically it's solving a linear equation. Okay, so basically after cap n periods, the principal has accumulated up to this kind of um, investment for a bank. Okay, and then they want you to collect that amount. If they would just lend it to you and you would pay every month by this cap m amount for cap m periods. Okay, so basically there's these monthly payments, they have different um, accrued interests up to, so basically from 1 all the way up to 1 plus r to the n minus 1. So that's a geometric sequence that we are summing. So essentially this is the equation that we're solving. All right, but then just remember this r is what? R is the monthly rate. Okay, so monthly rate. So that's what we're gonna reflect in our establishment of code. And basically here, the find payment function is exactly for each different loan, we're gonna just calculate the monthly payment there. And then if you look at the structure of the mortgage class, essentially you're gonna have a bunch of sequences. Okay, so these are lists. So everything else is pretty much the parameters that you need for each mortgage of yours. Okay, so remember we have three kinds. We have the fixed rate. We have like a fixed rate 30 years. Okay, so fixed rate, fixed number of years. We also have the second type of mortgage, which is we we buy some points. Okay, we pay a certain amount to buy percentages of the interest rate. So that's basically saying your it's like an initial payment you need to add a bit more, but then the interest rate has changed. Okay. And the third kind is like a teaser rate for an initial period. So we need to sort of like formulate all these in different kinds of mortgage in this large class. So the class here is what we're looking at is the mortgage class. We have three different kinds, but then for firstly we establish the fixed rate. Okay, fixed rate, fixed amount of years. But then the second and third, they're going to be treated as like subclasses. And of course, to initialize, we need, of course, the amount of loan, the annual rate. That's the APY that we gonna start with, and then the number of months is actually cap n, which is exactly the number of years times 12. So here basically, if you are comfortable with just making this modification, let's say for 30 years, it's going to be 360 that you want to plug in here. But otherwise, you can just directly utilize the modification. Okay, so as an input, that's totally fine. Right. So what do we care about? We care about the rate. Okay, so that's my R. So from earlier. So now remember the annual percentage yield, that rate is going to be divided by 12 for the monthly payment calculation. Okay, so that's going to be my R that's going to feed into the payment. So this is the monthly payment, which is a fixed number throughout like 30 years. Okay, so depending on how many months that you have. Okay, so that's the total. Okay, so total number of months is going to be plugging here. So basically, these are the attributes. So the loan self.long is the amount of loan that you have. The rate, okay, is R. The months is just going to be directly the total number of months is here. So the things with the asterisk, okay, so those stars, they're essentially what? They're essentially, you want to construct a list, okay? So basically for the payments, what you can do here is just every time you just append the monthly payment And then in the end, if you want to calculate the total amount of money that you paid, you can just sum that list. Okay, that's easy. But then here the owned, okay, self.owned is essentially what? It's essentially like at the end of each month you will have a new principal. Okay, so that's sort of like the recurrence we can easily calculate to also get a list. So just remember this is going to be the monthly principal. Okay, so monthly principal. So you can say this is like a K, which is what? Which is PK minus 1. That amount is occurring R% of interest, and then you minus M, right? So that's the formula that we're gonna realize, okay? So which is also not difficult to put down. And finally, there's a self.legend. That's basically saying, okay, now for each loan, right? Now I have specified all the things that I need for this class. But then to give it a name, okay, so we call it a legend because essentially later you're gonna see that we're gonna plot the curves. So each curve you would need a legend. So which is why they just use a legend here to indicate how you're going to describe the mortgage. But here we don't specify. Okay, it's just going to be an empty like a placeholder. And later you can replace it by a string. Okay, just based on what kind of loan that you have. All right. So that's the initialization. Okay. So basically, those are all the things that we need for the calculations to establish the entire period of, let's say, 30 years. Right. So I would need to mention here that for make payments is exactly constructing this recurrence relation. But here you are not really directly computing the entire sequence all at once. So what's special in the code that's provided later is that so they would do make payments for the total number of months outside of the class. But then just remember, for once a class is established, then you would have what's sort of like the pre-located memory in the system, so that basically for those attributes, okay, and for the lists, you can basically just append things into the pre-located memory. So that's somehow relatively nice, especially basically for every object, okay, or every mortgage, you would have two sequences, okay, so a sequence of monthly payment, so throughout the period, and then you would have the monthly principal throughout the period. So the first one is going to be like a constant throughout. The second one would be like decreasing. Okay, but
So,
then
Professor, if I
yes,
do want to append, the data type needs to be the same thing, or can I append the floats with integers?
you can, but it's just it's for your own interpretation purpose. You may not want to mix the things.
Okay, so but append function, I can use it for different data types. I can mix different data types.
You can do it. It's
Okay,
just
okay.
you may want to keep them in the same in the like same type so that it's easier for your sanity, okay, for
Okay.
interpretation. So if you look at the operation here, what do we do? So every time um so this is for the payment is going to be the constant here, okay? So constant monthly payment. And every time is I'm just appending one value here. So it's going to be a constant throughout. So this is for the sake of computing up to a certain month, how much I have paid in total. So this is kind of something you may want to keep because basically in the future if you want to study okay at a certain time point how much have I already paid how much principal of how much original principal have I covered throughout all these payments okay and then how much are left okay and then how much interest have I already paid, which are like three different kinds of values that they sum to a total of how much you have already covered. So this is not really trivial. So which is why they set up this kind of two sequences, and then later you're gonna see a few figures that are printable, okay, from the data. But here, so the monthly payment is just pending the same constant, but just realize that the principal here, okay. So self dot owned. This is the principal that's the previous, okay. So this is my PR. You can say this is my PR, PK. And this is my key pk minus 1. And so the reduction here is calculated as m minus pk minus 1 multiplying by the interest rate. So it's the way that the original derivation would work. But if you want to simplify the code, that's totally fine. So but essentially you are just uh, realizing the purple formula above. Right. And just to highlight, okay, this is 1 month. Okay, so this is each month. So essentially, you would need to make the payment for cap n times in order to establish the whole data. All right. That's what we're gonna do as a for loop a little bit later. Okay, so need a for loop later. All right, so that's making the payment. And yeah, okay. So the next function is get total paid, which is basically how much you have paid throughout the period of time. So it's going to be returning the sum of all monthly payments. And finally the str. Okay, the string of the object is basically what you want to what you want the class to return. Okay, for a particular object. So that's what we know already. But basically, currently there's nothing there, right? So then we continue with okay. Before we continue, anything so far? Okay, any questions so far for the initialization of the class? So pretty standard. Okay, just at the beginning, the important thing is the make payment function, which is like the monthly payment. That's and also the recurrence. Okay, so the current principal is the previous principal occurring the interest minus the monthly payment. All right. So now three kinds of mortgages. The fixed rate mortgage is basically where you would have the old mortgage class initializing with the interest rate R. It's basically so the fixed class in this fixed subclass in mortgage is exactly as we sort of like initialized. Okay, the mortgage class is originally fixed rate, but now here the legend is in terms of we are specifying is fixed with a percentage. Okay, is this is the APY with percentage. So basically, it's just saying, okay, this is a fixed rate with let's say 5%. Everything else is unchanged. All right. So that's pretty straightforward. But now the fixed rate with points, basically they're saying, okay, I need to pay some amount. Mm, so all right, so here basically this is just saying, okay, in order to get this R percent, okay, so to get this R percent, I need a down payment. So notice the initial payment is changed, okay? Initial payment is not zero anymore. So that's the amount that I need to buy the points. All right. So let's just quickly compare with what we had earlier. So originally you're saying, okay, I'm not paying anything to buy the points. But now here I just replace the original payment, okay, by that loan times points over 100. Okay, so that's the down payment to sort of like buy the percentage off. So this will be potentially a smaller R. Okay, just mm, okay, a little bit more challenging is the two rate. So now we have a teaser rate and a teaser period. So that's the this is the I would say the true rate, and that's still going to be my total number of months. Okay. Here, this is the teaser, which is at the beginning, and here this is the teaser months at the beginning. So what's interesting here is that the monthly payment is going to be calculated in two different ways. Mm. So here, initial teaser uh, payments are computed by initializing with the original fixed rate mortgage. So so what's that value in the example? Let me quickly refer back to the code. So initially, let me see. I think I have three kinds. Yeah. So well, the numbers I didn't specify. So let's quickly look at an example. All right. So this is saying, okay, I have 2.5% for 48 months, then 9.5, right? So the fixed rate is like 7%, or if you want to use 3.25% of the loan to reduce the fixed rate to be 5%, right? So that's the second one. The third one is, okay, I'm having a teaser rate of 2.5 for 4 years. But then for the remainder of the period, it's going to be increased to 9.5, right? So then how is it going to be calculated? So essentially, you're just saying, okay, I'm pretending it's going to be a 30 years, 2.5 rates of a loan, and I calculate the monthly payment based on that for 48 months. And after, at my 49 months, all the way down to the end, I'm going to reuse the principal at that moment to recalculate using this rate. So that's the sort of like the magic behind this kind of like a teaser rate kind of loan. So in terms of the code, if we go back, this is saying, okay, my teaser rate is what's the number there? 2.5 for 48. Excuse me. So that example, okay, 2.5%, 48 months, and that's 9.5%. 60, wait, 30 years is 360 months. Okay, so here, so initially, they would directly use the teaser rate, and pretending it's like a 30-year loan to calculate the monthly payment. Because once again, in the original initialization, okay, the monthly payment is here. All right, so it's already calculated. Right, so that's your teaser monthly payment already calculated. And then now you're saying, so here there's the teaser monthly payment. Okay. Okay, that's here. Teaser monthly payments. Okay, and then we need to specify also something new. So these are the new, these are the new attributes. So the teaser month is 48, the teaser rate, and of course the next rate, which is R over 12. Because that's for the remainder period. So that what we're going to reuse. Remainder period. All right. So now in terms of the payments, okay, it's going to be piecewise. So basically, for the first 48 months, it's going to be the initial payment that we have done in the initial mortgage class. All right. But then starting from the next one, we're going to erase the original rate. And we're going to also erase the original monthly payment by the new ones. So basically, that's saying what? They're saying at the 49 months, everything changes. So at that point, you see, this is the principal at 49th month and beyond. Wait. Yeah, so that's exactly only at 49. Okay, will this parameters be updated? So at the 49 months, I'm gonna calculate the self-down payment again. Okay, that's my monthly payment. But then it will be staying with that amount for the entire rest of the 300 and 12 periods, right? Months. And then the interest rate is also going to be updated. Okay. So that's this is going to be what? This is going to be 9.5% over 12. So that's something a little bit different from the fixed term interest rate. But then still, you are able to reuse the code that you have established earlier to formulate this new kind of mortgage. Oh, here, let me see. I have the principal, I have the rates, I have, okay, self dot months minus teaser months. Okay. Self dot teaser months. All right, so, and that's it. And then you just need to close it. Make sense? So basically it's that like at the 49 months, I'm gonna, for the remainder of, so this is 360 minus 48, this is 312. So all those months is gonna be paying the new monthly payment throughout. Okay, just Later we're gonna realize, okay, so if you have a teaser rate that much, then 48 months will not really pay off uh much of the original principle. So it's gonna still be really significant. Right. Okay, so once we have the monthly payment established, then everything is pretty much not difficult to handle. So, all right. Then okay, now here they establish what's called the function compare mortgages. So we have what? We have three kinds we want to compare. The fixed rate, the fixed rate with points, and the two rates. Okay, so the one with teaser. So these are the three kinds that we want to compare. So you can see that okay, fixed is the original class, didn't change anything. So these are subclasses that we have modified slightly, right? So we use the points to buy to initialize with a positive payment at the beginning, and then we have an interest rate that's better. So that's my interest rate with points. That's gonna be the second interest input. The fixed rate is here. Okay, the amount they are the same, right? So for the amount of loan, it's gonna be the same thing throughout. And then we have the variable rates. Just remember how you initialize the two rates as a mortgage. So the larger rate is at the beginning, all right? So the teaser rate is the second rate that you provide. So that's where your rate two is teaser. Let me put it in green. Purple. Let's make it purple. So this is my teaser. Okay, so that's gonna go here, and then rate one is gonna be the larger one that's gonna go here. Oh wait, which one is the teaser? Okay, so the one the rate one is actually the teaser. So if you look carefully enough, so that's my teaser here. So the teaser rate comes after, and that's my teaser months. Okay, these are my teasers. Yeah, now you see, okay, they specify the years, right? So they specify the years, and then you multiply by 12 to get the total number of months. And the total number of months will be that cap n is going to be fed into every one of the loans, right, throughout. And then for the variable months, let's say the teaser rate is for 4 years is going to be then 48 months. 5 years is going to be 60 months. All right. Yeah, just make sure that when you're playing with this mortgage class and the related functions in your live coding, just make sure that you get everything sorted out. All right. So that's good. Right. So the next line, okay, morts. Okay, so basically that's the list of mortgages. So remember the previous three lines are what? So the first fixed one is the first mortgage, fixed term, this fixed rate. Second one is another mortgage. The third one, two rates, is this the third mortgage. So now you have three objects in a list. That's easier for you to do a loop instead of so basically remember every mortgage you would have to do a for loop to calculate uh all the payments and all the principal owned from the total amount all the way down to zero. So you have two sequences you need to compute for each of these mortgages. So you put it in a list so that it will be easier for you to get a loop of loops so that everything computes in an automated format. right? And then later, let's say if I want to compare, let's say I have 10 different interest rates for the fixed term, then what do we do? So then you can write a loop to specify a list of rates, and then you will be able to do a loop, okay, appending the current mortgage into the original list. So that's the that dynamic way of sort of like constructing the data. Okay. So and then what's the point of using classes? Every class you would have a pre-specified list of attributes. Then you would not need to you would not have to write your own hand code your own local variables, right? Global variables. Just remember the attributes of classes are all global variables. So that's pretty handy. So that's pretty important. List of mortgages. Okay. All right. Now what do we have? So M for the loop is gonna okay. So these are making payments. Okay. So here this is M. Yeah. Let me just specify M. What M is. So this is M is for every month. Okay. For M in the range of total months. And now this is just saying, okay, for every month, for every mortgage, I'm going to do payment, right? So this is compute. So what are these sequences that I need? Yeah, right. Mm, make payment, make payment, make payment. I have, yeah, paid and owed, right? Paid and owed. Okay. So these are the two sequences I'm computing. And then this part is about the M here. Abusing the notation. Now here M is each mortgage. Okay, so these are mortgages. So now this is saying, okay, for each mortgage, I'm gonna print the total payments, and then we just run, right? So let's see. Oh yeah, well let's once again specify. It's basically what are the inputs. So this is saying okay, the loan is 200,000, right? So the total number of years is 30 years. So we are comparing the fixed rate of 4.5%. We have also 3.25 points percentage that we can put down to decrease the interest rate to be 3.5%, right? And then what the variable rates they are what they are uh mm, wait. Yeah, I'm a little bit confused about which is the teaser, which is not the teaser. Is teaser, yeah, teaser is going to be the smaller, which is now the second rate. So yeah, well, you need to be really careful about this. Hmm. Let's look at the code. The code is here. All right. Okay, so at the location here, var rate 1 is my 0.025, okay, 2.5%. And var months. So just what's nice about a class or the inputs of a function is that as long as you specify the input variables directly, then the order doesn't matter that much, okay, for your inputs. So namely here, your variable rate is going to be var rate 1, right? So var rate 2 is actually the fixed rate already. That's higher. So yeah, that's fine. So even though the order is a little bit different, but everything is still fine. So let me share this side. Just get some connections. So what's that? That's the teaser. Okay, that's the teaser. That's gonna directly associate to this and this. Right, just as an indication. Okay, so let's run the code. And make whatever changes that you feel necessary. But let me make sure that all the things are executed. So I need the original class. I need the subclasses. I need to compare the mortgages. And yeah, I'm done. So let's also try to, okay. So we are calculating the total payments. What's that? Let's get total payments. Meaning what? Meaning we are just adding up all the monthly payment we already established. Remember what the total payment is. Okay, the total payment is actually summing all the payments. Okay, so the sequence of self.paid is basically all the monthly payments that we have established, regardless of what kind of loan we have, right? And if you simply want to compute how much you have paid throughout the years, so as a comparison, 7% of fixed rate, you're gonna pay in a total of 479K. If you reduce the interest rate to be 5%, and you pay 3.25% of the loan upfront to buy points, it's 393K. So it turns out, even though you spend a little bit more at the beginning, okay, but in the end, the total amount is significantly less. All right. And finally, for the 2.5 at the beginning 4 years, and then you the rate significantly increases to 9.5%, it's going to be much more, okay, in terms of like 527K. So, and of course we can play with a little bit of different rates. So let's make it an even better teaser and even longer period. So let's make it 3.00. Wait. Oh, so that's the points. So the teaser rate is where? Teaser rate is here. So 20. So let's make it longer for, let's say, 16 months, depending on your choice. Or 70. Let's do 72. Okay, 6 months, 6 years. And let's make it 8. And let's make it 6.5, 6.5 for the fixed rate. And then to buy points, let's make it 4.5, and let's see. So indeed, you sort of see that the points significantly decreases the number of the amount that you need to pay in total, right? So now 2% for 6 years, that's actually also significant in the sense that, okay, the monthly payment at the beginning is much less. So now your interest rate is 8%, which is not that much comparing to 6.5. So essentially, the payments are roughly similar, right? But the larger the end game interest rate is, then the more that you have to pay uh, for the um, for the um, two rates loan, right? So I probably want to change it a little bit larger so that okay, 6.5, 4.5, and 8.5. Let's try that. Okay, 8.5 is not bad. Right. So as long as your code runs as designed, then indeed you will be able to see this kind of numerical comparisons of the data. But now, still, I would say, although it can successfully compute the stuff, but the downside here is that, okay, if you want to compare, you certainly would want to compare a little bit more features other than just the total payments or extracting certain attributes from the three loans, right? So of course, the second part of the lecture is going to be about plotting. So we have all these kind of different sequences. Okay, so we have the sequence of the monthly payments. We have the sequence of the principal reducing from the total amount all the way down to zero. So we care about, okay, how much we have already paid, how much interest have we covered, how much principal have we paid off, right? So these are certain things that we would like to visual the trend throughout the period, comparing different kinds of loans. So which is what we're gonna talk about in the second part of the lecture. But well, okay, in terms of in-class exercise. So create two mortgages, a fixed 5% loan for 30 years, and a teaser mortgage that has 3.5 rate for 5 years and then 7% for the remainder 25 years. And also compute how much is owned on each loan after 5, 10, 15, and 20 years, right? So now for the first two parts, that's actually not difficult. We just let's just go back to change. So we have 5% for 30 years. So 30 years, okay, 5%, we just change that to 5. Once your code is established well, then you are freely cha changeable for those parameters. So 3.5 for 5 years. So the variable, so that's 3.5, 3.5. 5 years is going to be what? It's going to be 60 months. And then the larger rate is 7%. Okay, so let's do it 7. And that should be straightforward. So in this time, we notice that okay, the most payment that you have to give for among the three loans is actually now the two rates ones. Okay, so the 3.5% of the teaser rate doesn't really help you much. Okay, so you would end up paying roughly 50K more comparing to the fixed term. So, all right, of course, if you want, so think about the way that you create these two mortgages outside of the function that we established earlier. So just use the class. Okay, so that should also be straightforward. So that's gonna be the fixed class, right? For this first one, and then the two rate subclass. Okay, the fixed subclass and the two rate subclass for the second one. So these are the things that you're gonna play with in the live coding part. So we are not gonna emphasize too much for now. But for now, think about how to compute after 5 years, 10 years, and 15 and 20 years. What's gonna be the amount owed? So what do you think? How do you get these numbers after 5 years, 10 years, 15 and 20 years? What do you think? So that's basically calculating the principal at certain time points, right? So essentially, what you can do is, of course, specify the first mortgage by some name, and then that name um, dot owned, and then this is going to be the list, right? And then you just access a certain time point, okay, certain index within that list. So 5 years is actually what is actually 60 months later, right? So remember the initial amount owned is actually the principal, and then after 5 years is going to be exactly the index 60. So essentially you would be doing what? You would be doing like a slicing of the original longer list, right? Slicing it by, let's say, 60 months, every 60 months. Okay, so that's something we can do by uh, using simple synthesis. So let me put it down in our notes and make sure to play with it so that later when we are doing live coding, we can be a little bit more efficient. I was playing with the live coding before class, and it turns out that indeed it takes a little bit of time to code things down for everything. But now let me stop the sharing for here. So let's call this loan one. Okay. So based on your class, okay, based on your class. So that's loan one equals to the class with the inputs. Loan two is the class with a subclass with the inputs. And then here, what you need to do is, let's say loan one dot owned. So that's a list, right? That's a list. So you can do slicing, right? So it's starting with 5 times 12 and ending at let's make it 5, 10, 15, 20, and then 25, 30. Okay, so that covers everything. So it's gonna be like 30 times 12 uh, plus 1. Remember, it doesn't include the end. So for slicing, right? And then for the step, it can be just 5 times 5 times 12. Wait, let me think. For slicing, we need a colon. For slicing, we need a colon. Right? So that's of course this is something you can realize when we do the live coding session. All right. Any questions so far? So yeah, they're just lists, okay? So they're just lists already computed in your classes. Then so this is exactly the way that we utilize OOP to deal with our own tasks. Okay, so matplotlib. So this is the package. Okay, so this is the Python package for doing matplots. Library, or you can call it a package. All right, so we want to, of course, visualize the certain outputs comparing different kinds of mortgage data. Okay, so that's where we utilize this kind of plotting tool. So also there's another mathematical package that's very important. That's what's called the NumPy. So the trick here is that basically you would need to for certain tasks. Remember earlier we haven't imported any packages for our coding purpose, but now for plotting and also for this kind of NumPy is in the sense that for certain functions and certain numeric values, let's say pi and e. Okay, so they are not really predetermined in Python. So you may want to utilize some of those to help you with numerical computations. I think there's a line. I think there's a line to import the packages, but I sort of so here usually this is NumPy imported as MP. Okay, so usually it's gonna be import NumPy. So make sure that your names are called correctly as MP. So this is saying what? This is saying, okay, I'm trying to import the package, but now the nickname is MP, so that it's saving a little bit typing for your coding. So this is the nickname name. And similarly for Matplotlib, it's usually imported as just a plot, PLT, PLT. So that is a little bit less typing that you need to do to call the class. Okay. So now it's going to be mp.py. So pi is an attribute, which is the number in the NumPy package. Okay. So then you will be able to directly utilize that number there. Here we also want to specify what's called a linspace. So basically, this is slicing the interval from 0 to 10 into 11 data points, including the endpoints. Okay, so from 0 to 10, excuse me, from 0 to 10, if you would want to include the endpoints 0 and 10, and also all the integral points in between, so it's going to be what? It's going to be 0, 1, all the way up to 9. So it's actually a total of 11 points. So you need to be careful here. So that's where the 11 that comes in. So if you want to say, okay, I want to have the interval from, let's say, 0 to 100, and I want to get the numbers by 20th, right? So 0, 20, 40, 60, all the way up to 100. Then you may need to think about how many data points are there so that you're not really getting fraction numbers throughout the slicing. Okay, so these are number of points, including endpoints, both endpoints. So basically, this is slicing the interval from A to B into n minus 1 equal pieces. Okay, so that's if you call it an n. Okay, so this is like a b n. So this is b minus a over n minus 1 times I and plus a plus this for I from 0 all the way to n minus 1. All right. So just be careful here. All right. Okay. So yeah, these lines are already here. So import. If you look at the matplotlib pyplot. So this is actually a package that is a really long syntax name. So here we imported this as PLT and NumPy as MP. So these are the nicknames. So that will be shorthand, okay, for your typing, okay. Nickname for packages. But now these packages, essentially, they are classes. All right. They're just prescribed classes that you can utilize. And now, so you can think about this linspace as just a list of numbers. Okay, you can think about it as a list, but essentially this is going to be an array we're going to talk about later. So this is a NumPy array. So we don't really talk about the arrays directly in Python because an arrays is actually something really special in NumPy. In general, it's just a list. All right. Let me get to the code. So in the code, what do we need to see? We need to see this. Let me hide this line and this line and this line first. So now, firstly, what's x? X is oh, I have I have a third curve, so I don't really need to plot. So here, let's print the type of x. So the type of x is, if you look at the output here, x is a list or an array. But now, what's the specific type? Is the ND array inside NumPy. Okay, so this is only a data structure. You can say a data structure in NumPy. So there's specific requirements. And now, basically, this is just a list of numbers. And then you would, so those are the x values. You then associate, okay, so x with all these sine values. So that will give you a bunch of points on the sine curve. So x cosine x, right? So that will give you a bunch of points on the cosine curve. And then x-axis will be, okay, so there will be different curves. So let's uncomment all these. So what do you need to do? You need to get a figure. So this line right here is saying, okay, I'm gonna construct a class called figure, okay, in my MatplotLib package. The name of that class is gonna be FIG. So that's gonna essentially, if you look at this is saying, okay, the figure name is FIG. It's actually in the class of matplotlib.fig.capf figure. So this is actually the object. Let's also type the type of this our figure, and also let's plot the functions. Let me plot a few. So these are really traditional functions, but sine and cosine they are established in NumPy. Okay, so look at the class; it's actually pretty long. So which is now we know everything's an object, everything is a class. Okay, so that we know what that is. Oh, excuse me, not here. Here, the figure is a special class, but now the curves. So let's see. That's my sine, right? The sine function goes through the origin, so 0, 0, all the way up, and that's my cosine. Okay, in orange. Now x, right? So that's my linear function with a slope 1. So basically, if you're looking at the coordinates, okay, so that's my 2 as an input, and that's my 2 as an output. That's so basically everything is pretty working as expected. And then what else? So yeah, for exponential function here, you also can call it from using NumPy. So we can also look at that. And also let's plot sine plus cosine. So here, this is specifying the shape of the style of your curve. Okay, remember everything they have different color, right? But they are all in the solid curve. So if you do this kind of um, uh, specification of style, and what do you see? You see this is the, like a dashed line, right? So this is the sine plus cosine. Remember, sine plus cosine is actually giving you a high point when the input axis what is pi over 4, right? So which is somewhere less than 1, right? Right, yeah, right here. Yeah. So that's my dashed line in red. And okay, wait. Okay, 1 times exponential. So yeah, exponential is growing. So that's my exponential growth. Mm, one more thing. Notice the semicolon. So here, if you get rid of the semicolon, then so if here notice for the output we only have a figure, right? So this is the figure that's representing our function curves. But if you don't have the semicolon, then what can what do we see? We will see something a little bit not comfortable. So if you do the line like what we have done from before without any semicolon at the end, you would have this kind of output. Okay. So this is just the output code, okay, for this plot operation at the end. Remember, basically for Python, it will for every code cell, it would output whatever output the last function call would give. So this plt dot plot is indeed a function call. So it will give you some text output. So here, if you want to hide it, okay, without popping something you don't want, okay, then you just use a semicolon. So this is really special for Matplotlib. Okay, so if you get a semicolon, then basically this suppresses. It will suppress the text output of the function call here. So now you don't really need any. So yeah, that's something you don't need. So which is the semicolon that you want to include here. So you only care about the figure, right?
Professor, if I do
Yes.
have a matrix, which is, let's say, 5 by 10, and I want to choose particular row and column, are we talking about that too?
You have a matrix, you want to make it as a column vector, right?
Yeah.
That's I'm not 100% sure. I think that's something we may talk about in NumPy, but
Okay.
that actually is actually like a one line thing in Python. So it's exactly in NumPy. So even if not in this class, but that's that's not gonna be a really advanced topic, which you eventually can do. Okay. So yeah, well yeah, I'm pretty sure that's something you're able to do in using NumPy. But yeah, it's coming up soon. Um,
So we
mm,
will be talking about vectorizing of matrix.
um I I'm not 100% sure at the moment.
Okay.
To be frank, I'm pretty sure there are certain things that will be done in NumPy, but in terms of vectorization, I'm not 100% sure. I'll get back to you on that next time. But as for now, vectorization, what I know is that it's actually just like one line of code. And even if not in this class, they talk about it in machine learning quite a lot. So I
Okay.
okay,
I'll look
yeah,
into
let me try to prepare for that because it should be there in when we talk about NumPy. But yeah, well, I'll get back to you on that. So this is indeed a very important question. Factorizing a matrix is by no means difficult, but we do need to cover it. Let me put it down somewhere. So vectorizing a matrix. So that's actually a topic in NumPy. But yeah, we should definitely get to that. Let me also turn up the volume a little bit so I can hear you a little bit more clearly. All right. So let me see. Okay, so those are the functions that we are calling and the style of the curve. Okay, so that's that. Um, And if you okay, and something about the lines, the lean space. Okay, so this is from 0 to 3. Okay, we didn't really specify. We don't really specify how many datas are there. So here we can. So if you say okay, I do 10 data points from 0 to 10, including the endpoints. So if you think about it, this is what this is saying. I'm subdividing it into 9 intervals. So including the endpoints is going to be 10 data points. Okay, so now from 0 to 10, using nine equal pieces. Every subinterval is in the length of 1 plus 1/9, right? So 10 over 9. So if you look at the data here, that's computed. So you see this is like a discretized sine cosine curves. Okay, so if you want to get smoother graphs, you would say, okay, I may want to use a little bit more data points. But then what's the downside? So the downside of using more data points is that in the future, possibly you would have a large array. Okay, so just think about the mortgage problem that we have earlier. So in the mortgage problem for 30 years, right? You would have 360 data points. And then the more data points that you have, of course, you would have much more data that you can make the graph smooth. But remember, usually your graph is just like the 70% width of your screen. So using too much data point would make it possible to make the points really sort of like concentrated. And one problem is that the graph may not look really nice. The second problem is that the computational cost is going to be significant, especially if you have to compute like hundreds and hundreds of iterates. So one option is that do slicing. Okay, so here this is the example where the slicing is a little bit too coarse. Okay, so you may want to get like say 30 points. So if I do 30 points, then okay, it's much smoother, right? So if I do, let's say 40, then that's sort of a relatively good. Okay, still you can see like the zigzag behavior right there, right? So you don't really need a whole lot of data points to get a good representation of this cosine function, sine functions. So yeah. And once again, we have the semicolon there to suppress the function output of plot. And let's change it back to 10 to sort of revisit the behavior here. So it's from 0 to 10. I'm using 9 intervals to get 10 data points. So being 0, and then this is something like so yeah, well, so that's 10, 10 over 9. So yeah, 10 over 9 is larger than 1. So indeed. So 1 is in the middle. So we're leaning towards the right. And the next one is also larger than 2. And then larger than 3. So yeah, it's getting more and more leaning towards the right. So indeed. Right, and here let me also run this line. So this is the feature that you're able to save the figure. Okay, so this is just saying okay. For my let me see. Yeah, this is my figure 2. Okay, so y value, they are the inputs. a linear space from 0 to 10 with 10 data points. Fig 2 is going to be the name of my plot. And then here are my plotted curves. And then now, if I want to get the picture of figure 2, how do I get it? So if you're running on your local machine, that should be in your in the folder of your script, okay? But now, if you are doing it on Colab, what can you do? So you are able to find it. So this is the icon here. So that's files. Click that, and then that's my first figure. Okay. So if you fear that you are not able to download the file on your machine, so you still can do it. So from Colab, okay. So that's something you will be able to download. So for whatever figure that you want to save, then what you can do here is to save the figure as a file. So here, this is the PNG file. All right. So plotting the mortgage class. So yeah, we have the 3 mortgages. So later we need to modify the classes a little bit to sort of plot the curves. So what are the curves that are plotted? So make sure. Okay, this part is really straightforward. So for a principal of 10K with 5% of interest rate and 20-year of mortgage, what you do here is the principal plus the original principal times the original principal plus the principal times the interest rate, and then it's going to be an exponential growth. This is the figure name. This is the plotting the values, which is just a sequence, okay, just a list, and then give it a title, give an X label and Y label, so they're directly represented here. So that's my X label, okay, years of compounding. That's my Y label, is vertical printed, and then the title of the figure. So these are something really basic you definitely should play with. And this is the future value, okay, after that number of years. So values -1 is the last entry of your sequence here. Okay. Let me see. Augmented mortgage class. So all those things, they are the same from before. But now we have a few different functions that we are plotting, okay? So that's saying, okay, I'm going to plot the amount of paid, but now it's a sequence starting from the first entry all the way down. Yes.
I got a question. So could you use numpy numerical Python, like the import of it? Could you import that, and does that have attributes that allow you to like compute the mortgage without going through each step of class initialization? Like I know you can do probability functions with it. I was curious if you could do financial functions.
So NumPy would do something really fundamental, just like sine, cosine function. They are the functions that you sort of that's necessary for your scientific computations. But in terms of mortgage, you may want to search for packages, but they are so elementary that you just do a few loops to compute. So they probably don't write it, but it's also possible that they have more advanced financial features written by somebody else.
Yeah.
So that always try to search for any package that you want to utilize.
Okay.
But then there's gonna be the issue of reading through the introduction and also just correctly implementing these packages in your Python.
I know with like NumPy and SciPy, I use that a lot in this Socratic processing class with like the probability models. So
yeah,
just curious.
for probability. So let me stop recording for now, and we're gonna continue next time.